The heading indicator is required anytime a pilot operates under instrument flight rules, and because of that, a person looking to get their instrument rating must understand how it works. So in this video, I'm going to explain everything you need to know about the heading indicator so you can operate under IFR.
Welcome to Free Pilot Training. I'm Josh, and today we're talking about the heading indicator.
Some pilots refer to this instrument as the directional gyro because this is a gyroscopic instrument that tells you what direction you're going. Well, fancy that. Anyway, this is one of the 6 primary flight instruments. Most pilots refer to these as the 6-pack. And if you want a 6-pack, go ahead and grab yourself one over at freepilottraining.net. Don't believe what everyone tells you. You don't need to go to the gym for that. Anyway, the heading indicator is one of 3 gyroscopic instruments that you'll find on an IFR certified aircraft. If you're about to take off and there's not a heading indicator in there, you'll have to operate under VFR. Now, we call these gyroscopic instruments because all 3 of these use a gyroscope in order to give the pilot information that can be used in flight without having to look outside at visual references. We'll talk more about the actual gyroscope in just a minute, but when it comes to navigation, the heading indicator is one of the best tools you have available. It's awesome for determining your heading when it's used correctly. Before we talk about that, let's take a quick look at the Federal Aviation Regulations. I want to take a closer look at FAR 91205, and this reg should look very familiar to you because this is where we can find our VFR minimum equipment requirements. But this is also where we need to look to determine the minimum equipment needed to operate under IFR as well. And as you can see, the heading indicator isn't listed? Yes, it's there. The heading indicator is what they're calling the gyroscopic direction indicator. So as you can see, while we don't need this guy to fly under visual flight rules, this thing has to be in the aircraft and working to operate legally under instrument flight rules. But check this out. We also need a magnetic direction indicator, and that's just a fancy name for the whiskey compass. So why can't we use the compass instead of the heading indicator? Well, the first reason is that when you use a whiskey compass, it seems to operate backwards. Now, I talked a little bit about this in the last lesson, but let me re-wake up those brain cells for just a second. Let's say you're facing directly north on a 360 heading. In order to make a turn to a 330 heading, we all know that we need to make a left turn to do that. But the whiskey compass seems to indicate that we need to make a turn to the right to get over to a 330 heading.
Now, after you start the turn, this will all start to make sense because the compass will actually move in the opposite direction of your travel.
And that's because your airplane is on the outside of the whiskey compass. But by using a gyroscope, really smart people figured out how to put the airplane inside of the compass rose on a heading indicator. And this allows us to fix the backwards problem. Another problem with the mag compass is that it's also subject to magnetic dip, and these cause the whiskey compass to have turning errors and acceleration errors. And we actually just talked about that in the previous lesson if you haven't seen that yet. But this is why we use the heading indicator, because it's way more accurate for precision navigation, which is exactly what we want in order to operate under IFR. Okay, now we can talk about why we call this thing a directional gyro. Once again, the heading indicator uses a gyroscope to give us a really reliable heading indication when we're flying in the weather. So let's go into a little bit more detail on what exactly a gyroscope is. Have you ever tried to balance a bicycle while the bicycle is not moving forward? It's almost impossible, isn't it? And if you pedal really slowly, the bike can still be pretty difficult to balance. But once your bike starts moving faster, it becomes a lot easier to keep it upright. This is because the wheels become resistant to outside forces as they begin to turn. As the wheels turn faster, they want to continue turning around that inner bearing because of inertia. And anything that bumps into them has to overcome inertia in order to make a change in this state of motion. This means that a gyroscope and things that rotate in space are more rigid and more resistant to wobbling, or any change for that matter. And this principle is what we call rigidity in space. And this is how our heading indicator is able to sense changes in the heading of your aircraft. Let's take a quick look inside of the heading indicator and see exactly what's happening in there that gives this thing its rigidity in space. As you can see, just like the bicycle, we need something to turn this gyroscope. Now, there are some aircraft out there that use electrical motors to do this, but most training airplanes actually use suction from a vacuum system to turn this gyro. And this is exactly why they suck so much. You're welcome.
Anyway, I know that you're not going to believe me now that I told you that this system sucks, but it actually works really well. And we're not going to expect you to memorize a vacuum system schematic or anything like that. But just know if this thing isn't getting good suction, then the heading indicator is not going to be very accurate.
This means that if your gyro isn't spinning, or if it's not spinning enough, you're not going to get this rigidity in space. This is going to cause your heading indicator to be less accurate. And actually, this is why I personally wait to slave the heading indicator until I'm doing the run up, because this is going to allow the suction from the vacuum system to get this gyro spinning nice and fast before I set it. And this is going to give me the most accurate heading possible. Okay, so this suction spins the gyroscope inside of the heading indicator. Now, notice these two rings around the gyro rotor. These are what we call gimbals, and these allow the aircraft to move around the gyroscopic rotor without affecting its position. It just stays rigid in space, and these gimbals are then mounted to the inside of the heading indicator, so when your airplane turns, the gyro just stays right where it's at. Oh shoot, I just ended that sentence in a preposition. Anyway, this gyro rotor stays still and is connected to a gear which turns some other smaller gears which ultimately turn the heading indicator relative to the aircraft. This allows the gyroscope rotor to maintain its position in space as the aircraft turns. Now, here's something important to remember. On older analog heading indicators, they do not know which direction magnetic north is. They don't receive any kind of magnetic signals, so as the aircraft is turning, these little gears just turn the heading indicator to whatever heading you had set in there. So the pilot, that's you by the way, has to align the heading indicator with the magnetic compass periodically. And I'm sure you already know this, but we call this slaving the heading indicator. Now, these two instruments are not connected in any way. All we're doing is pushing down and twisting this guy to match the magnetic compass. When we push this button, the compass card becomes disconnected from these little gears that are turned by the gyro, and this allows us to set whatever heading we want. So I'll just twist this little guy and match it up to my magnetic heading, and then we're good to go. Now, you might be wondering why we have to do this. Why doesn't the heading indicator just stay this way? Well, one of the reasons is because when we shut down the engine, the gyro stops spinning. The other reason is because of something called precession. Let's look back inside the heading indicator. Notice how many moving parts are in here. All these parts that move are affected by friction. Friction will cause your heading indicator to drift from the heading you set in there. And this is what we call precession. And actually, something else that can cause precession is the rotation of the Earth. Now, I know that some of you here might not believe that the Earth is a ball shape, and it's okay to be wrong. But depending on where you are on the globe, the Earth rotates at about 15 degrees per hour. So if you set your compass to north at the beginning of your flight, in about an hour, north is going to be in a different spot. And this is why you need to reslave your heading indicator every 10 to 15 minutes or so in flight, in addition to the run up. Just remember, if you're in the air, the airplane needs to be in straight and level flight in order for this to be accurate if you're slaving the heading indicator to the compass. And that's because of those compass errors that we talked about in the last lesson.
But what if I'm flying a newer aircraft with one of them newfangled heading indicators?
Newer aircraft with digital flight instruments often have something called an HSI, or a horizontal situation indicator. These look very similar to the traditional heading indicator, but the way they work is a bit different. Aircraft with an HSI have a device in them called a magnetometer, and this guy senses the Earth's lines of magnetic flux. And no, I didn't just make that word up, it's real. Anyway, the magnetometer then relays this information to the aircraft's IFR system, which stands for Attitude and Heading Reference System. The IFRS then tells your primary flight display, or PFD, what this heading is, so you can actually tell which direction you're going. And because the magnetometer is constantly sensing the aircraft heading and sending this updated information to the PFD, you don't have to reslave your heading on aircraft that use these systems.
Kids these days, they'll never know what it was like to have to manually input your heading. What will they think of next? Artificial intelligence? Anyway, thank you guys for watching. I really appreciate it. Be sure to check out freepilottraining.net to get cool gear like this hat, and we'll see you next video. See ya!